transpose of a matrix. So how to do this? For example, A is 1, 2, 3, 4. Now, how to write transpose? The symbol is A, T. So here we have to write row as column. Okay. See, 1, 2, I will write it in column. Next, 3, 4, I will write it in column. This is nothing but the transpose of a matrix. Okay. See, we can write row as column or column as row. Both are one and the same, I tell you. Column, write it as row 1, 3. Column, write it as row 2, 4. So these two are same. So the transpose of a matrix is nothing but writing rows as columns or columns as rows. That is called as the transpose of a matrix. Let us consider 3 into 3 matrix. Now, how to write transpose of this matrix? Write the first row as first column, second row as second column, third row as third column. Okay, so this is nothing but the transpose of the matrix. Next, we have to study permutation. Okay, so permutation matrix means what? Here in every row there is only one element, that is 1. Others are zeros. For example, 1, 0, 0. In each row there is only 1, 1 and the remaining is 0. Here also 1 and this is 0. Now, similarly, 1, 0, 0, okay, 0, 0, 1, 0, 1, 0. See here, in each row, there is only 1, 1, like this. This is called as a permutation. Now, let me consider one example. If A is find out the permutation matrix of the given matrix. Then it would be PA. Okay, so P into A. That is, see here, first element, remaining are zeros. So row into column, when you multiply, you will get 1. Okay. Next, here you will get 2. And here you will get 3. Because only the first element is 1. And here the last element is 1. So last element of every column, that is 7, 8, 9. So 7, 8, 9. Next, second one. So second element of every column, that is 4, 5, 6. So if you look at this matrix, permutation matrix with the given matrix A, here the first row remained same. Only thing is the second and third row are interchanged. So this happens when you do the permutation. The rows are interchanged. So this is the meaning of permutation. Now, inverse of a matrix. So see here, inverse of a matrix is written like this. Inverse is equal to adjoint of matrix A divided by the determinant of A. This is the formula. Let me solve one problem first. Let A is equal to 1, 2, 3, 1, minus 2, 3, 4. Okay. Now, let me write its adjoint. So, adjoint means what here? principal diagonal elements must be interchanged. That is, 4 comes here and 1 comes here. Next, the remaining elements sign is changed, but the numbers remain in their places itself, but only thing is you need to change the sign. 2 remains here, minus 2 becomes plus 2. 3 remains here, but plus 3 becomes minus 3. This is the adjoint of A. I hope you understood. Adjoint of A means what? Principal diagonal elements are interchanged. They remain in their places itself, but only thing is you need to change the sign. Now, determinant of A. Okay. So, what is determinant of A? You need to multiply this, cross multiplication. 1 into 4 minus, okay, minus 2 into 3. So, that is 4 minus into minus plus 2 3s are 6. Therefore, it is 10. Now, according to the formula, A inverse is equal to adjoint of A, that is 4 2 minus 3 1 divided by 10. Okay, now let me simplify this. 1 by 10 into 4 2 minus 3 1, and this is yes, 4 by 10, 2 by 10 minus 3 by 10 and 1 by 10. Simplify this. This is 2 by 5, right? And here it is 1 by 5 minus 3 by 10 and 1 by 10. So this is the inverse of a matrix when the size is 2 by 2. Now, what happens when the size is 3 by 3? That we will study now. How to find out the inverse of a matrix when the size is 3 by 3. So, first, the formula is as usual, that is A inverse equal to adjoint of A divided by its determinant. Formula is same. Now, first let us find out the adjoint of A. Before finding the adjoint of A, we need to find out cofactors of A. Cofactors of A. How to find out cofactors of A, that I tell you. See, now I will write it as, instead of numbers, I will write it as A11, A12, A13. Okay? A11, A12, A13. Next, 1 means row and this is column. First row, first column, first row, second column, first row, third column. Similarly, 2 to A23. A31, A32, A33. This I need to find it. Now, how to find out A11? So, A11 is the thing, but see, the first element is A11, right? So, now, ignore its column as well as its row. Okay, ignore this. What is left here? 2, 5, 3, 1. It's a determinant we have to find out. What is that? 2, 5, 3, 1. Okay, so what is this now? 2 into 1 minus 3 into 5. So it will be 2 minus 15. Therefore it is minus 13. Similarly, A12. Okay, so A12 means you need to ignore this column and this row. Okay, this column and this row. So what is left here? Minus 1, 5, 4, 1. Minus 1, 5, 4, 1. It's a determinant. That is minus 1 into 1, minus 1, minus 4 5s are 20. Therefore, it is minus 21. Next, A13. A13 means leave last column and first row. So, what is left here? This one, like this and this. So, what is left? Minus 1, 2, 4, 3. Minus 1, 2, 4, 3. So, here minus 3 minus 8. Okay. Therefore, it is minus 11. Next, A14, sorry, not A14. Now, first one is over, A21, that is this one. So here you have to leave this row and this column. So this row and this column, what is left? 2, 3, 3, 1. 2, 3, 3. So it is 2 minus 9 and that is minus 7. Okay. Next. A22. This one. Means you have to leave this column and this row. What is left? These 4 here. So, no, this one. This and this. 1, 3, 4, 1. 1, 3, 4, 1. So, this is 1 minus 12. Therefore, it is minus 11. Next, A2. This one. So, leave this row and this column. Okay. This row and this column. What is left? 1, 2, 4, 3. 3 minus 8, that is minus 5. Next, A31 means leave this row and this column. What is left here? 2, 3, 2, 5. 10 minus 6, that is 4. Next, A32. So, this one. Leave this row and this column. What is left here? 1, 3 minus 1, 5. So, this is 5 plus, minus into minus becomes plus 3. Therefore, it is 8. Next, the last one, A33. Okay, this one. Leave this column and this row. What is left here? 1, 2 minus 5, 2. This is 2 plus 2, therefore it is 4. So now we need to write the cofactor matrix. How to write that? A is equal to, see here, A11 first minus 30. Next, A12 minus 21. Next, A13, that is minus 11. Next, A21 minus 7. A22 minus 11. Next, minus 5. 4. 8. 4. So, this is what the cofactor matrix. Okay. So, this is cofactor matrix of A. Now, this is minus 13. Okay, multiply the symbol. Minus into minus becomes plus. So, it is 21, not a negative. Next, minus 11. Next, this is plus 7. Next, minus 11. 5. Then 4. Minus 8 and 4. So, this is actually the cofactors matrix. Okay, because we need to consider it is very important. Plus minus plus, minus plus minus, plus minus plus. So these are the signs of the matrix which is of cofactors. Now the transpose, which is nothing but the adjoint of A, and that is equal to now this is the adjoint of A. Now let me find out the determinant. See, 1 into cross multiply 2 minus 15. Okay, minus. So the next one is 2. 2 into, okay, minus 1 minus 20. Plus 3 into minus 3 minus 8. So this is 1 into minus 13 minus 2 into minus 21 plus 3 into minus 11 So now minus 13, okay, minus into minus becomes plus, 21 into 2, 42, minus into plus becomes minus, 11 threes are 33. So now what is the answer? 42 minus 46. So this is minus 4. So the determinant value is minus 4. What is the final answer? So as per the formula, A inverse is equal to adjoint of A divided by its determinant. Okay, so A inverse equal to, so minus 1 divided by 4. This is the determinant and the adjoint. So this is the final answer. So this is the procedure of finding the inverse of a matrix when the size is 3 by 3.